Okay, so we're gonna do the second part now. The second part, we're gonna start at the bottom of page 91 where it says speed revisited. Okay, let's go ahead and jump into the example number 6. Finding instantaneous rate of change. Find blah, blah, blah for the function, blah, 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 blah. So limit, this is example number 6. And so the rate of change for here, for the speed, we're saying that limit as h goes to 0, we have h f of t plus h minus f of t. Okay, for here, we're going to do this where f of t is equal to 2 t squared minus 1 at t equals 2. So f of 2 is going to be equal to what? F of 2 is going to be equal to 2 times 2 squared, so it's going to be 8 minus 1, so it's going to be 7. So 2 and 7. Limit as h goes to 0. Where t is, I'm going to put that guy in there, so I'm going to get 2t plus h squared minus 1 minus, this was 7 over here. Oh, we're going to get t is equal to 2 here, right? T is equal to 2. And I'm going to get h on the bottom. So we get limit as h approaches 0. What do I get? I get 2h squared plus 4h plus 4 minus 1 minus 7 over h. Limit as h goes to 0. 2 times 4 is 8, minus 1 is 7, minus 7 is 0. So I'm going to have 2h squared and 8h over h. Limit as h goes to 0. I'm going to end up with 2h plus 8. So as h goes to 0, I'm going to end up with 8. Okay, so the instantaneous rate of change is going to be what? Is going to be 8. This is the instantaneous rate of change. It's going to be 8. Okay. Example number 7. Example number 7 is basically the same thing, but now we're going to use the free fall equation. If I use the free fall equation, blah, 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 blah. So f of t is going to be equal to 16t squared. This is my equation. Find the speed of falling rock example where at t is equal to 1. At t is equal to 1, I'm going to get 16. So it's going to be 1 and 16. So if I put 1 in here, I get 16. Limit as h approaches 0. I get f of t is equal to 1 minus f of 1 over h. Limit as h approaches 0. If I put 1 plus h in there, I get 16, 1 plus h squared minus f of 1 is equal to 16 h. Limit as h approaches 0, I'm going to get 16h squared plus 2h plus 1 minus 16h. So I look at the constant, I get 16 minus 16 is equal to 0. Limit h approaches 0, I get 16h squared plus 32h over h. Cancels out. Then h goes to 0, so this guy goes to 0. 32. So 32, which kind of makes sense, right? If you think about it, right? Because the instantaneous rate of change of the speed instantaneous rate of change is going to be what? 32, right? 32 meters per, 32 feet per square second, right? Okay. Okay, last but not least, we're gonna get the sensitivity. Sensitivity is how quickly or how sensitive is Y to X. In other words, as delta X changes, how quickly or slowly does delta Y change? And that's what the sensitivity is here, okay? So let's go ahead and actually just do the example here. Example number 8, measuring sensitivity to medicine. Okay. A patient enters the hospital with a temperature of 102 degrees and is given medicine to lower the temperature. As a function of the dosage D, measured in milligrams, the patient's temperature will be that. So T of D is equal to 99 plus 3 over 1 plus D, okay? Find and interpret the sensitivity of the patient's temperature to the medicine dosage when D is equal to 1. So when D is equal to 1, if I want to find the sensitivity, I want to find the rate of change. So in other words, I want to find the instantaneous rate of change when D is equal to 1. So I'm going to get what? Limit as H approaches 0, T of 1 plus H minus T of 1 over H. That's the instantaneous rate of change at T is equal to, D is equal to 1, right? So we just go ahead and calculate this out, right? Limit as H approaches 0. I'm going to get 99 plus 3 over 1 plus 1 plus H minus 99 plus 3, 1 plus 1 over H. So the 99s are going to cancel out. Limit as H approaches 0. What do I have left here? I have 3 over H plus 2. I have 1 plus 1 here. Minus 3 over 2 over H. Limit as H approaches 0. I'm going to get 2H plus 2. I'm going to pull the 3's out here. 1 minus. Oh, so what do I have here? You know, let's not pull out the 3. Let's go ahead and just run it. So I'm going to get 2 times 6 minus 3H plus 2 over H. If I combine the denominators here, so the 6 and the 3 and the 2 here cancel out. So on top, I'm going to have limit as H approaches 0, I'm going to have negative 3H over 2H plus 4 over H. This H and this H cancels out. This guy's going to go to 0. So I end up with negative 3 over 4. Negative 3 over 4. So as at D is equal to 1, the rate of change of the temperature is going to be negative 3/4. So every dosage you go up, you're going to have, the temperature is going to go down 0.75 degrees. Okay? Again, the bottom it says, this means that when the dosage is equal to 1 milligram, a small additional dosage will result in a drop of the temperature of about approximately 3/4. Okay? So that's how you'd run it. Okay? Any questions here? All right, if there are no questions, you can continue to work on your homework.